All right, in this video, we are going to talk about the 9 puzzle, the final project, and how to tell whether or not the user has entered a valid input and whether or not we should make a swap based on the user input. So I'm going to show you 2 different ways on how to do this. One is just sort of straight computer science type way to do it, and the idea behind it is pretty straightforward. The implementation of it is a little bit more difficult. And the second way I'm going to talk about is with uses a little bit of math, but actually the implementation of it is easier in the long run. Okay. All right, so let's work through the first way. So the first way is, let's just take a look at some examples, and let's say that the user input is a 5, okay? So what you're going to do is you're either going to need to locate the 5 itself inside the two-dimensional array, and I talked about that, how to do that in the previous video, or you're going to have to work off of the 0. So if you find where the 5 is located, then what you're going to do is to check to see if the 0 is either directly above or below it, or to the right or to the left of it. If you work off of the 0, then you're going to do the same thing, but just with the 0, and you're looking to see whether the number that the user entered is directly above or below the 0, or to the right or to the left of the 0. So you probably thought about that at some point and realized that that's how you do it. You can do it either based on the 5 or based on the 0. I'm just going to go with the 5 in this case, what the user inputted. All right, so the first step would be to find what row and what column that the 5 is in, right? The 5 is in row 1, column 1, right? And then what you would want to do is look at these numbers here. Look at the number that's directly above, the number that's directly below, the numbers that is directly to the right, and then the number that is directly to the left of the 5 once you find it in there. Okay, and so that's what you would do. And so here, whatever the table is, you would look at the value, see what values in row 0, column 1. So notice I got that by subtracting 1 from the row. And then to look at the value that's directly below, you would add 1 to the row, right? So that would be row 2, column 1 would be this 8. And you're looking for a 0. You would look at the value that's directly to the right, right? You would add 1 to the column. So that would be in row 1, column 2. And look at that number. And to look at the value that's directly to the left, that would be looking at the element that's in where the column would be 1 less. So that would be row 1, column 0 right here. Okay. Right, and so that's one of the ways that you can do that. You can also do that with the 0. Find where the 0 is located and see if the 5 is directly above or below, or to the right or to the left. Okay. So there is a catch to that, right? And let's say that the user enters a 7, let's say. And then you would find, okay, the 7 is in row 1, column 0. Okay. And so 7 is on the edge of the board right here. So you can certainly look at the one that's above it or the one that's below it. That's fine. You can look at the ones that's to the right. But the minute you try to look at the one that's to the left, right, if you did the same thing you did over here and subtract 1 from the column, you'd end up as -1 for the column, and that is not a valid column number, right? And so if you try to do that, your program's going to crash. So you would need to add some code in there and say, hey, if the row number or the column number is less than 0, well then don't look that up. It's the same thing if the 0 is on the edge of the board, right? And if you're going by looking up the 0 and then looking above and below and to the right and to the left, then over here, if you tried to look at column 3, right, that would also crash the program. So if you're going this way, right, the idea is pretty straightforward here. You just have to look above or below, to the right, to the left, but there are some little twists that you would have to add some if statements, to say, hey, if the row or the column number is smaller than 0 or bigger than 2, then don't do that part. Okay, so there's many different ways on how to handle that, but that is the basic idea. Look up where the user entered number is and look above and below, to the right, to the left, to see if you find a 0, or similarly look at the 0 and look above or below and right and left and see if the user entered number is there. Okay. Again, you're going to have to be careful of these edge cases where the number or the 0 is on the edge of the puzzle. Okay. So that's one way to do that. The other way, the second way I'm going to talk to you about, involves a little math, so you're going to have to bear with me a little bit, and but this way is actually pretty easy to implement. It involves something called the Taxicab Metric, and the Taxicab Metric is a way to measure distances, and this kind of looks complicated here, but it's not. The main thing that you would need right here is the formula, which is down here on this page right here. So if you take a look at this image right here, it talks about what the taxicab metric is. Right? In algebra, we're used to the straight line distance, right, between two objects, the distance formula, right? If you've taken college algebra class, there's a formula, right, that lets you calculate the distance between 2 points. So the taxicab metric gets its name from big cities, basically, where, like, say, Manhattan, it's also called the Manhattan distance, where there's lots of large buildings, right, and you can't take a straight line path from, say, like one intersection to the other. What you have to do is, since everything's kind of laid out on the grid on the downtown part, so you have to go sort of parallel or perpendicular, right, to through these cross streets. Okay, and if you count the distance that you go in blocks, right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right, it's going to take you 12 blocks, right, to get from point A to point B. Whereas if you could take the straight line distance, it would be a lot shorter. But you can't do that, right, because there's buildings that you can't go into, and you certainly couldn't drive a car if you're in a taxi, right? You certainly couldn't drive your car through the buildings. Okay, so that's why this is called the taxicab metric, right? This is the actual kind of distance that you're going. All right, and so if you look at that taxicab metric, right? Here I have 2 points, x1, y1, which is the red point, right, which I can kind of move around, and this blue one, which I can kind of move around as well. Okay. You can see, maybe you remember from the math class, right, the distance formula, the straight line distance formula is right here. Okay, and you can see the distance between those two, straight line distance, so that would be directly going straight from the right, from the red point to the blue point, is 2.82. And this is the formula for the taxicab metric right here. It's the absolute value of x2 minus x1 plus the absolute value of y2 minus y1. And that would be indicating right here, if I start at the red point, I went 1 unit, 2 units, 3 units, 4 units, like that. Okay. So how does this apply to the 9 puzzle? Well, the thing is that you could actually use either of these formulas. Right? If I want to look above or below and to the right and to the left, I could use these formulas, right, to calculate what the distance is between these 2 points. So if you know the distance of the row in the column that the 0 number is in, and the row in the column that the user entered number is in, then you can make these calculations. And if you notice, right, above, directly above or below, or to the right or to the left, right, all of these would equal 1. Okay, so that's one way to say, hey, are those two numbers directly above each other, directly one's below the other, or one's directly to the right of the other, or one's directly to the left? Another way to say that is that the straight line distance, right, between the two comes out to be 1 if you calculate based on the row numbers and the column numbers. Okay, So x1 would be the row number of one. This would be the row number of the other. These two would be the two column numbers. All right, and so you can see you could actually use this straight line distance formula, although it's going to come out to be a double because of the way the calculations go. And this taxicab metric just turns out to be much, much easier because you can write this as an int. If your values x1, x2, y1, y2 are ints, well then so will this taxicab metric be. And that makes it easier to compare using equality. Comparing double values with equality, right, is not always reliable. All right, so just again, get the row and column of the 0, get the row and the column of the number that the user entered, and then make this calculation, right? If it comes out to be 1, well then you know 1 is above or below or to the right or to the left of each other. And then all you would have to do is swap the two numbers, and that's it. Okay, so implementing this is much easier than the way I showed you before. It just takes a little math to kind of understand the idea of what's going on. All right, and either way is fine. The main thing is that you get it done, so you should go with whatever way you feel is easier for you.